All right, welcome everybody to this month's all hands meeting for the Minority Serving Cyber Infrastructure Consortium. I'm very excited about this month's guest speaker, but before we get into that, I want to do a couple of quick little updates, and then I will turn over the reins to Dr. Jorge Crichigno from the University of South Carolina and let him do his presentation about science and networking for all. But a couple of quick updates. I'm sure many of y'all are aware that the CC Star deadline is approaching at the end of the summer after the Labor Day weekend. But the MSCC CI Facilitation Services is offering some consultations to y'all to help you with your proposals. But the deadline to get that help from the MSCC is rapidly approaching. And in fact, it's next week. But that gives us a little time still to help you to review, etc. So if you are interested in getting some help with your CC Star proposal submissions, if you're doing one, please feel free to reach out to the Assistant Director of CI Facilitation Services for the MSCC, Lauren Michael. Her email is on the screen, and I believe one of my colleagues is going to start throwing some slacks or some messages into the chat functionality for me so that you can have it there as well.
Question.
Yes.
Is there a, going back to the previous slide, is there an application that Ms. Michael would need us to complete to sort of get MSCC's assistance?
I think it's just as simple as sending her an email, and then she'll start a dialogue with you to find out what all she can help you out with.
Okay, sounds good.
Let me get her email and throw that into the chat for you real quick. All right. So moving right along, I'm going to turn over this slide to our CI engineer, Jennifer Kemp. Jennifer?
Hello, good morning, good afternoon, everyone. So we actually are looking for input from you all. So we have created a quick 1-question survey that you can access here, and we'll also throw the link in the chat. So we understand that needs and demands are dynamic and always changing, right, in an institution. So we want to stay with those trends that you all are experiencing and continue to be useful and provide resources for your current needs. So we would like input as to what services or offerings are kind of most impactful to you right now that you would like to work on within the next year. And it's really just 3 checkboxes. So the options are listed here on this slide. We do have a brief description of each of these items on the form itself as to what they are. So we wanted to give you a moment now to complete that. Thanks for putting that in there, Emily. And if you have questions or concerns, feel free to reach out either to Lauren or myself. I'll put my email in the chat as well. If you need more time to review, but if you can, we just ask that you pop over to that survey and click 3 checkboxes for us. Thank you.
Thanks, Jennifer. All right, so the MSCC has been doing a lot of stuff over the last year or so, and we're making all of the content available on the website, and there are a number of different hot links and QR codes on how to get to all of that content, including the YouTube playlist that has the recordings from all of these all hands meetings, as well as the recordings from the annual meeting closing keynote and the closing keynote from the community co-hosted community exchange from Internet 2. Those events that were happening in Atlanta back in May. And there's a whole bunch of other cool things in that playlist. So I encourage you to take a peek at that when you have a moment, as well as peruse the various presentations and content from all the different workshops and other events that we've been doing over the last year. And then we've got some things coming up. So we've launched a CI community of practice, and it's meeting monthly. I believe it's on the 3rd Tuesday of every month. And the next one is August 15th. So you got a couple of weeks to go until that comes up, but there are details available as to the types of topics that are covered. I believe the community that's participating determines the agenda and what will be talked about month to month. So I encourage you to join those and see what all is going on, and perhaps see about getting some assistance from your colleagues and others. And then finally, and this is going to help us seg into our guest speaker, is join us in Minneapolis in September. I think it might be kind of cool then. So we are doing a half-day workshop on that Monday of TechX in Minneapolis in September that's going to focus on science DMZ and networking for all. It's going to talk about and demystify a lot of the terms related to these things. It's going to, lay out what all the different words really mean and what the concepts are. And then additionally, the program for TechX continues for the most of the remainder of the week. And we invite you to fill out an application to attend these events, and funding will be available for accepted applicants from the MSCC, TCUs, and HBCUs. But there is a deadline on that application. That application is due on, I believe it's a little bit before midnight on August 13th. And I know the team would really appreciate seeing those applications come in fast and furious. So we invite you to, see what all is going on and think about whether you can make this work in your fall plans. And with that, I would like to turn it over to Jorge, who is going to share a fabulous presentation with us, sort of teeing up what all is going to be covered in that workshop in September. Jorge?
Thank you, Emily. I just want to confirm that you can hear me well and you can see my screen. Thank you for that information. Aside of this presentation, I just want to briefly mention I attended Internet to Technology Exchange in 2019 the first time, and it's just a great experience, not only for the tutorials, but for the presentations, tons of presentation, very interesting. So if you have the chance, I strongly encourage. Typically, I bring even my students to that event. So this presentation is about Science DMZ and networking for all. This is what we will be organizing a workshop or tutorial during Technology Exchange. My name is Jorge Crichigno from the University of South Carolina. And I'm here with Elie Kfoury, also an assistant professor from University of South Carolina, and Jose Gomez, also from University of South Carolina. I want to mention my colleague from South Carolina State, Nikunja Swain. We are developing a lot of cyber training material with funded by NSF, Office of Naval Research as well. So South Carolina State is involved in this project as well. So briefly, what we'll be doing in September. So as I said, we're organizing a tutorial on science DMZs and other network-related topics. The tutorial will be co-located to Internet 2 Technology Exchange. That is September 18, 2023. Now, we can provide access to some material that we will be covering because it might be helpful if you plan to apply to NSF CC Star. So all these topics are extremely relevant to NSF Campus Cyberinfrastructure program. If you look at that program, Area 1 and 2 are related to Science DMZ specifically. Most of the proposals on Area 1, as far as I remember, are about developing Science DMZs. So what are the goals of the tutorial? Understand the network elements required for high-performance data transfers. Describe the key elements of a Science DMZ. If you're going to put a proposal on Science DMZ, I mean, you will learn all these key elements. How to measure performance of different congestion control algorithms. why is that important? Because TCP is at the heart of the solution and the problem. So the reason why we cannot achieve high performance data transfer sometimes is because TCP has some mechanism over there in its core, that is the congestion control. And then we will talk about perfSONAR. perfSONAR is a tool that allows us to measure end-to-end performance. It's a monitoring tool. So if the network is not working well, perfSONAR will tell us in terms of metrics. We will learn how to use perfSONAR, how to visualize measurements. And at the end, we will briefly talk about Fabric. Fabric could be or can be a very useful tool for learning, for research, for test ideas at scale. So Fabric is a network that is covering the whole US and internationally. It has some points outside the US as well. So those are the goals of the tutorial. Intended audience, IT professionals, CI engineers, high performance computing specialists, research systems. These are people that work on campus networks or ISPs, research and education networks. And also at the end, you see IT educators. So we are committed to help IT educators. So we have a lot of libraries, virtual lab libraries that are used in courses, community colleges, universities. Prerequisites, basic knowledge of computer networks. Okay, so first, why are we doing this? Why NSF/CC star? Why Science DMZ? And the reason is because it's very difficult to get high performance to transfer very large data in regular networks. So on the right-hand side is a graph that shows how over the years the volume of data is increasing on ESNet. ESNet is a national network connecting national labs and research centers, universities, etc. On the y-axis is the volume per month, and this is just 2018. I'm sure that it is keep increasing. So it looks like a linear graph, but really this is exponential because we have a logarithmic scale. So in summary, a lot of data being transferred over the networks, and if you try to move that through your regular network, you won't be able to. So even if you have a flow, let's say coming from your data center that has to go to somewhere to your collaborator network or to some cloud system, even just 1 gigabit per second, which is not that large. But if there are some packet losses in the middle, maybe there is a firewall or an intrusion prevention system or NAT, or maybe a switch that has very little memory for buffering, you will have packet losses and you will have performance degradation. So those are the typical limitations in a regular network. So how is this manifest? And this is a very famous graph from ESNet. And what it shows is data transfer between two devices. And this is over a 10 gig network. So what we have on the x-axis is the distance between the two devices in milliseconds. And on the y-axis, we have the throughput, the performance. So in an ideal world, when we don't have any packet loss, everything is perfect, yeah, we will have good performance. This is the purple curve. Now, if we just inject one packet loss out of 22,000, what you have is all this curve, the red, the blue, and also the theoretical, which is the green. We see how the throughput collapses as the distance between these two devices are separated. Beyond 10 milliseconds, the performance is really bad. And this is just one packet loss out of 2,000. Most likely you might have more packet losses than that, and you will get even worse performance. So that's why NSF is investing in this issue and how to solve this problem. One way is using Science DMCs, deploying a Science DMC on your campus network. And that lead us to Science DMC. What is a Science DMC? This figure shows the way that we did at USC, University of South Carolina. And what you have here is, first, we have a service provider connecting us to the wide area network, Internet 2, regular commodity internet. And then we have our enterprise, we call enterprise network the regular network. Here's where our regular students are. Then we have a co-located network that we're calling this Science DMC. And there are some elements. There are not that many, but let me briefly talk about them. You see this box here, perfSONAR. It's just a server that will measure the performance to my colleagues in the world in their respective networks. We have this that is DTN. DTN stands for data transfer nodes. Think about just a Linux device that is tuned for high performance. We have also switches. These switches, and these are switches with a good amount of memory for buffering packets. Buffering packets means that these devices will hold the packets as they come through the ingress port. They hold momentarily, and then they leave through the egress port. So if the buffer is too small, you will have problems, a lot of packet losses, and then performance degradation. If the buffer is too big, you have more than what you need. Probably you might end up with something called buffer bloat, which is when the packet waits so long in the queue and you have more latency than what you might have. So maybe there is a way to optimize. But those are the main elements. The other elements that is not shown explicitly here is the security tailored for high speeds. And notice that we are missing here the firewall. You see a firewall, but in the enterprise network, but not in the Science DMC. So what is the problem with the firewall? So the firewalls have some issues. They might process packets, inspect the packets as they are traversing using general purpose CPU. And general purpose CPUs will be too slow for high performance. So what is the way to mitigate potential security issues? Well, one way is always having security at the end devices and the Science DMC, perfSONAR. The other is using access control list. Access control list is a mechanism to make sure that only the organizations that are allowed to access your device are accessing it. And access control lists are implemented in the data plane, in the muscle of the device. If we say the control plane is the brain of the device, slower general purpose CPU, the data plane is the muscle, is faster, is in hardware. It can process packet in real time. So that is the difference. So that is the, in a very quick overview, Science DMC. So if you plan to put a proposal for NSF CC Start, basically this could be the idea behind it. So the elements, making the case for a Science DMC, there are data transfers happening in the campus network, and you might need to improve the performance. And here we have some more issues occurring at layer 1, physical layer, layer 2, data link layer, layer 3, network, layer 4, transport layer, and then the applications. I will not go into detail, okay, but if you are curious about all these, I can refer to you to good tutorials or even the cloud system that you will have access if you want to many of these elements, exercises, how to configure these devices in an emulated environment. Science DMC in the US, these are from, this picture is probably has 5-6 years already, but anyhow, is a good picture to realize all the Science DMC or awards in CC Star across the country. Now, these are some topics that we'll be covering during the workshop. First, let me just say a few things. These are the main elements of the Science DMC. First, the high throughput, friction-free wide area network path. So your provider has to have a good network without friction. Friction-free means that there won't be packet losses because buffer issues or could be also for inspection, firewall in the middle. Now, data transfer nodes, these are the end devices. Key configuration issues here are TCP. TCP plays a key role in performance. So that's why we will talk about TCP here and TCP related issues. First, let me start with TCP congestion control. If we want good performance in our network, we have to adjust the TCP congestion control parameters. So TCP congestion control, most of the devices still use the principles that were designed or applied in the 1980s. Specifically, whenever there is a packet loss in the network, what TCP does, the TCP congestion control algorithm, is to reduce the rate drastically in half. If the sending rate, let's say, was 10 and there are packet losses, it's going to be cut into 5. And if there's a packet again, quickly 2.5 and so on. So that is very drastic. Now, TCP will try to increase again slowly. That is the additive increase slowly. Multiplicative decrease is very fast. And that could be a problem for high performance when there are large round trip times. And that's the reason why we have this problem of throughput as the distance increase. We will talk about that. We will do experiments in the workshop, and we will configure TCP traditional congestion control algorithm. We will also talk about more modern congestion control algorithms. Specifically, there is one that is called TCP BBR. Not all the campuses use. At USC, we use this congestion control, but some other campuses use different congestion control algorithm. BBR is relatively new congestion control algorithm. It represents a disruption on traditional congestion control algorithm because it doesn't follow this additive increase, multiplicative decrease control law. Instead, what TCP BBR will do is try to figure out, whenever I have a sender and a receiver, in the middle of the network somewhere, there is a bottleneck. And that's where packets are queued on the device just before the bottleneck, typically a router or a switch. So TCP BBR tries to figure out what is this bottleneck, and then once it figures out, it will set the rate to that bottleneck. For example, sending rate from the sender will be equal to the bottleneck. Now, from time to time, every 8 round-trip time cycles, TCP will test if there is more bandwidth. That is what we call the probe. maybe that's the case. So the TCP BBR will increase the rate, the sending rate. If that is not the case, what's going to happen is more packets will be in the queue, larger round trip times, and then TCP BBR has to drain the queue. So reduce the rate again and then go back to normal. So that is the strategy. So we will be playing with TCP BBR in the workshop. That's another topic that we'll cover. We will also optimize performance using something that is called parallel streams. And this is very typical when we transfer large data sets with specific tools for high performance. So on the left, what we have is the FTP model. So FTP, file transfer protocol, is a protocol and application for regular file transfers. So if you use FTP, well, you have one data channel, one TCP connection. The data channel is used to transfer the data, and then the control channel to send control messages, start the transfer, end the transfer. So now, if we want better performance, the strategy is better if we open several TCP connections between the two endpoints. And that's what we call streams. So all this is being automatically, provided we use the right tool. For example, Grid FTP or Globus. You might have heard about Globus. We will do some exercises. We will learn how to measure the performance when we use a parallel stream or a single stream. And there are good reasons why the performance is better. For example, parallel stream combat the random packet losses, and also parallel stream mitigate TCP round trip time bias. We will also measure performance, learn about the maximum segment size. And if you're not familiar with maximum segment size or MSS, this is the maximum segment, that's the name where it's coming from, that can be sent by the TCP socket. Typically, it's 1500 bytes because that must be inserted in an IP packet and then in the Ethernet payload, right? But if we have a network that can handle jumbo frames, 9,000 byte frames, then the maximum segment size could be larger. Why is it important for high performance networks? Well, back to the TCP problem. Whenever there is a packet loss, I will put my pointer here. Whenever there is a packet loss, let's say this red curve here, there will be a drastic decrease in performance. And then we slowly go back to higher sending rates. And this slope, how fast we're getting back to higher rates, is proportional to the maximum segment size. A larger maximum segment size will lead to much faster recovery after a packet loss. Okay. These are topics, again, that we will be covering, the buffer size also, without going too much detail. What the buffer, the TCP buffer is the amount of memory that we allocate to TCP. So TCP is ready to send this to the other end. If this buffer is very small, performance will be very bad. So what is the TCP buffer size, the appropriate? Well, at least it has to be equal to 2 bandwidth delay product. And the bandwidth delay product is equal to the bandwidth. What is the bandwidth between the sender and the receiver? What is the delay? You can consider the worst case scenario, multiply by 2 and set the TCP buffer size to that amount. We will also be doing that during the workshop. So that is just one of the elements. That's all those elements are related to DTNs, data transfer nodes. Another element of the science DMZ is perfSONAR. And perfSONAR has to do with measuring the current state of the network. What is the current performance, let's say, to my collaborators' network, from my network to my collaborators, is end-to-end. So the figure, this is from ESNet. Here, on the right-hand side shows a campus network, a server, let's say a DTN, and on the other side, another server. And between these two, there might be many networks, regionals, RNE backbones, many heterogeneous networks. So if there is a problem, it might be a little bit difficult, tricky to figure out where the problem is. How would a problem manifest? Lower performance. Maybe the connection between end-to-end should be 10, but we're getting few megabits per second. So, and that's where perfSONAR is very useful. perfSONAR allow us to, if I have a perfSONAR node in my campus, if my collaborator has a perfSONAR node in his or her campus, and also if the regionals have perfSONAR, well, maybe we will be able to figure out quicker where the potential problem is. And this is end-to-end. So maybe the problem is in my campus, or maybe is between the service providers, the regional and the backbone, or maybe is at the destination. Now, with perfSONAR, we will be able to figure that out. So this is an application that is able to detect, to help detect soft failures. Soft failures are those failures that are that happen in a network, and the network is still able to work, but the performance is degraded. For example, what is a soft failure? When a router starts dropping packets, let's say, and well, some packets will be dropped, but others will be sent all the way to the destination. But the fact that there are some packet losses is going to be reducing drastically the bandwidth. The system will still work, but not with a good performance. Soft failures are difficult to detect. perfSONAR is a really good tool to detect such failures. So, as I said, is a network measurement tool. It facilitates diagnosing, visualization. Jose will show today a tool that is used for visualization with perfSONAR. It's called Grafana. And perfSONAR can collect metrics such as latency. I apologize for this. I will just turn my phone off. perfSONAR can collect metrics such as throughput, latency, and packet loss. Now, if all the networks from the source to the destination have perfSONAR, the idea is that, well, maybe from my network to the first network, the performance is good, but from the first network to the second, the performance is bad. So we are trying to find out where the problem is. And this is a view of perfSONAR, the different layers. We will be learning how to use perfSONAR in the workshop, how to use the tools, how to use the P-scheduler. So the tools are applications. For example, here we have this iPerf3. This is an application that allows us to measure the throughput, maximum throughput from a node to another node, from A to B. Ping is more popular. It allows us to find what is the round trip time between two nodes. The P-scheduler is an application, an important part of perfSONAR that allow us to schedule tests. I want to schedule performance test from my network to my collaborators' network, maybe 3 times per day or 2 times per day. So that's the PS scheduler, will help us automate tests. Archiving, and then we have visualization. An example of visualization, I think this is perfSONAR 4. I want to mention that we will be using perfSONAR 5, the latest perfSONAR, and we will have a full library of laboratory experiments from the very beginning, what is perfSONAR, how to configure, all the way to scheduling tests and visualizing in Grafana. And with that, also I want to mention, before I finish this set of slides, we will have a short demo shortly. Some websites, I want to point out to our website, cybertraining.html, the last one here. Emily, I will be giving you this set of slides. And we have been doing this for the last 5 years. We prepare training material. This is for IT professionals and educators. If you're an educator, if you want to use in your class, you're welcome to contact us. If you just want to learn one of these technologies using our platform, feel free as well to contact us. For example, P4 programmable data plane switches. These are libraries that teach the learner how to program P4 switches or cybersecurity tools, more programmable switches, network tools and protocols. This is focusing on Science DMZ. We'll be using this library during our workshop. And many more, network management and open source tools for intrusion detection, such as SIG and BRO. So that is the first part of this presentation. What I want to do right now is to switch to Jose. Jose, are you ready to show briefly perfSONAR library?
Yes. Thank you, Dr. Crichigno. I will share my screen. Hello, everyone. This is Jose Gomez from the University of South Carolina, and I will provide you a brief overview about the perfSONAR library that we are developing here at USC. The aim of this library is to provide hands-on lab activities to learn perfSONAR. The library has 2 parts. The first part will cover the basics of perfSONARs. These are the pscheduler command, using the web interface, psconfig templates, how to configure pscheduler limits, and how to visualize basic results with using the Grafana dashboard. Part number 2 will cover the use cases. We are going to use perfSONAR as a debugging tool. We are going to see realistic scenarios where you have an issue in your network and you use perfSONAR in order to detect and fix these issues. These labs are based on perfSONAR 5. The perfSONAR 5, the toolkit, the perfSONAR software runs inside a Docker container, which is very manageable and easy to set up. Network topologies are implemented in Mininet. I will be talking about that soon, which is a network emulator that facilitates us creating realistic network scenarios. And these virtual pods are available through the NetLab platform. So if you're interested on having an early access to this library, please feel free to write your email address on the chat and I will gladly provide you access. So these are the labs that we are developing. Currently, we have 7 labs covering part 1, which is understanding perfSONAR components. We cover, for example, basic features like how to set administrative information, how to set regular tests using the graphical user interface. We talk about the pscheduler command, which is an essential component of the perfSONAR suite. We talk about how to create a psconfig template, which is a script that is understood by a perfSONAR node in order to run regular tests. Then we configure the limits of the test. This means, for example, I want to allow that other perfSONAR nodes can test throughput for only 30 seconds, no more than that, because otherwise it could overwhelm my network. We show how to set those permissions in lab 6. And now in this short demo, today I will show you how to visualize these scheduler measurements using Grafana. Then in part 2, we are developing this part. We are going to use perfSONAR as a debugging tool. We are going to see realistic use case. These are issues that the ESNet team had and documented and posted in their website. For example, observing the impact of TCP window scaling and small TCP buffer size. We're going to talk about that. We are going to use perfSONAR to see the impact of using small buffers in your network. And we also are going to see the effects of packet reordering and how we can use perfSONAR in order to detect those kind of issues. We are currently planning to develop 10 labs, but this is not restricted to 10 labs. We might develop more because the platform is very flexible. And that is what I want to talk about now. This is basically the organization of the lab. I will skip this and talk about the platform because I'm going to show you a short demo. Basically, we are using Mininet to implement the perfSONAR labs. Mininet is a network emulator. We use MiniEdit, which is a graphical user interface that facilitates to create different networks. And another thing that is very important on this lab is that we can run all these activities using a single virtual machine.
So I will just add very quickly. I will add something very quickly. It's for the sake of time, just keep in mind that we have just about 5 minutes. These tools are available to you today. Of course, the libraries are not finished yet, but we will have much more for the day of the workshop. But if you are interested, feel free to contact Elie or just leave a message here and we will give you access to the platform if you want. The other thing that I want to mention is that Jose is indicating that all this is happening in one virtual machine, but this is real. It's a real Linux box. Is exactly as you would be deploying in your Science DMZ or your campus network. It appears to be a simulation tool, but it's not simulation. It's a real Linux box generating real traffic, and this traffic could even go to internet or any network you wish. With that, Jose, feel free to continue. Just keep in mind, Jose, we have very limited time.
All right. So just to finalize, previously we had a library. We currently have that. It has several VMs. It has several VMs, but the topology is fixed. With this tool, if you think about any scenario that you might want to test, you can do it with Mininet. You can easily just create a topology. And another thing that I want to mention, just to finalize, we can integrate several devices here because perfSONAR nodes are running using Docker containers. You can bring your containerized application and run here, run using MiniEdit. For example, you can run before switches, firewall, and other containerized elements in order to make your network environment more interesting. With that, I will jump into the demo and show you a basic scenario that we created here with perfSONAR. This is NetLab. If you're interested, I can provide you access. Just write me down in the chat and I will grant you access. So let me log in here and I will show you, this is the lab environment. These are the reservations that I currently have. You can schedule a lab by yourself. Let me show you this very fast. Here I have a course. In this course, you have some of the libraries that we developed. The one that we are currently developing is Introduction to perfSONAR with Mininet. You click there and you can see the 7 labs that are currently available for you to run. And today I am going to show you lab number 7. You can click here and you can select a pod, which are these resources that you have here. Schedule a lab, clicking on the red line, or scheduling ahead on time, just with playing with the calendar application. I will go back because I already have a reservation and show you the results. So we schedule a reservation and then we enter the lab. Here we have a single virtual machine, which is hosting our virtual labs. I will click on this machine and you can see here we have the environment. Let me minimize this just to show you that this is just a Linux VM that has Mininet and MiniEdit here. In this tab, you can see the lab manual that has step-by-step procedures in order to configure what we want to show in the lab. Let me just navigate very fast and show you the result. And with that, I will finish my presentation. So this is the lab manual and this is the client machine. Each lab manual provides a context by giving an overview. We have the objectives, the credential to access the machine. We have an introduction explaining the basics of this lab. We talk about the lab scenario, and then in section 2, we jump into the step-by-step procedure. In this lab, we basically show how to use Grafana to display the results that are produced by a perfSONAR node, in this case, perfSONAR 1. Here we show how to run the emulation, how to load the topology, how to set the environment. We use MiniEdit here. We use pscheduler to create the results, and then in section 4 we show how to configure Grafana. Basically, here we run Grafana. We show step by step how to access the tool and how to configure it in order to have the results propagated into a dashboard. So this is a step-by-step detail procedure that we show in this manual, and as a result of this lab, you should be able to, for example, see throughput measurements, RTT measurements or retransmission, or add any metrics that you are interested in that is collected by the perfSONAR node. If you want to know how to do that, you can take this lab, this manual as a reference in order to have that working for your scenario as well. With that, I will finish my presentation, and I don't know if you have any questions.
Thank you, Jose. And before, because we're running out of time, Elie, I don't know if you want to briefly talk about Fabric and what we will be mentioning, talking briefly during the workshop as well.
Sure. Yeah. See if I can share my screen real quick. So as Dr. Crichigno was mentioning about Fabric, this is an international infrastructure that allows researchers to test their ideas at scale. So it provides computing resources, storage resources, networking resources, and you can decide which sites you want to use, and then you will be getting machines, and then you will deploy your code, and then you can run the experiment. You have links in the US and also externally to Europe and other places as well. So what we are doing with Fabric is developing also cyber training material. For example, you can see here some libraries that can be implemented over Fabric, and we think that it's a good place to implement those libraries because it has an integrated Jupyter Hub, which is basically a notebook, a Python-based notebook, so you can write your code, save it, and it's very easy, reproducible. So you can basically create complex networks, run the experiments. As you can see here, this is a screenshot of one of the labs where we have 4 sites. There's a P4 switch, and we decide how we can do the connections all through the code, and everything is there documented. You can run throughput tests using iPerf, which we mentioned also on these slides. It has the same organization as the labs that Jose was showing. We start with the background, and then we have step-by-step to complete the experiment. We have some labs that we developed so far about P4 programmable data plane switches, from the basics all the way to a complex application like Q measurement. And we have some upcoming lab libraries. One of them, which is the interest of this workshop, would be perfSONAR, as well as high-speed networks, how we can tune science DMZ network. So we will be deploying that over Fabric. And the advantage of that over Mininet and the emulated environment is that we are using the real physical propagation delay, and these are real links, 10 gig, 100 gig links. So you'll be able to really reproduce how a current network would look like, and you can run the experiments there and test some new protocols if you want to design new ones. To give you an idea, I'm not going to run that, just this is how it looks like. So this is the Python notebook. You have some background, and then you start step by step, you execute the cells. From first, you define which sites you want to use. For example, here we have 4 sites. You can select, you can specify which ones you want to use, and then how many resources you want. For example, if you want a server with 4 CPU, 8 GB RAM, and so on, all of them you can mention here. After that, we do the connections. We have the connections there. We add the NICs. You would have the physical topology ready. And after that, we're going to start installing packages that are necessary for the labs, like the software switch of P4, some other tools like NetTools, Scapy to generate packets, all the way till basically writing the P4 code. So we're going to show how we write the P4 code step by step as well. Everything is explained. And finally, you will be able to run the experiment. In this example here, we are calculating the Q occupancy. We are getting that from the switch and provides us with very granular reports. So you would run here and you should be able to see that on a collector. For example, if you run here like throughput test, you should be able to, using the collector, get what is the values. For example, here it's around 300 microsecond. This is the Q occupancy for this iPerf test that is being run now. Notice here that we limited the rate to 50 megabit, which is small. So the queue is not being formed because we don't have high rates. But then if we re-execute that without rate limiting, you can see now the queue occupancy goes all the way up to 200 millisecond. And we are averaging these, by the way, the samples, we are getting them per packet, but we are averaging every 1,000 just to make it more readable. But this is the power of these P4 switches. You can get per packet visibility. And by using it over a real network, you should be able to get really nice experiments and results.
Thank you, Elie. Let me just pause you there, but I think that was very clear. Thank you. And yeah, I hope that this is giving you a taste of what the workshop will be, the tutorial in technology exchange. Emily, with that, I just want to open this for any question or anything that you might find convenient.
Thank you so much, Jorge. We do have a few minutes, so those of you on the line, I know people have been throwing in a lot of stuff in chat. Jorge, much to your happiness, I think you'll hear, I've been collecting all of the lab requests that I will send over to you in an email. But there were a number that came in through chat. I've got them all in a email for you for later, so you do not have to collect all that. So that's all covered. And then we've got one question as to how folks can connect with you all around this. Can we throw your email addresses into the chat real quick for folks?
Yes, I see here, Mauricio, thank you. Yeah, my email, I will put my email here, and I don't remember my phone of my office, but I will be writing in a second here. Okay. Either a phone or email is fine.
Wonderful, thank you. And then I believe you're going to be sending me a copy of your presentation, so we'll be making both the presentation as well as the recording from today available on the YouTube playlist here, probably within a week or so, just to manage expectations. It takes a little while to get these things turned around. But questions from the crew?
Any questions, but I just wanted to comment on the thoroughness of this presentation and the importance of this type of work. When I was at NCCU and I posted a little bit of this, we knew that we needed the science DMZ, and when we started looking at that, the perfSONAR was integral in our understanding our network. We believed we had really good throughput. You know, we're connected to the REN and and we had, you know, bandwidth, but there were things that was identified through the perfSONAR. We worked with Duke in establishing that. So thank you all, and thank you for those labs. I mean, that is really, really helpful. And then I'll just say to my colleagues, if this is your first foray into learning more about a science DMZ, you know, look through that a little bit more. And then what we did was we used a CC Star planning grant to inform whether or not we fully needed the science DMZ, because it is about the throughput and about the research. And what we identified through the stakeholder pieces, and again, that's something that we started with the CI planning with stakeholder outreach. You realize on your campus that faculty are doing stuff around IT organizations often because they don't want to bother the IT organization. And so the CC Star planning grant as an entry point into the CC Star grant where you can implement the science DMZ is really, really important. And then I'll put a plug in for our CI plan community of practice. We meet monthly, and you all as members of MSCC will get those notices of that. So please join our workshops and our discussions so you can learn more about that. But take advantage of the resources of MSCC around the CC Star. And if it isn't, you're not ready for this one, put it in the back of your mind because there'll be additional opportunities to get started. So you don't have to jump right into CC Star. You can do a planning grant first, and then I'll be quiet.
Leah, thank you. So I'm throwing a bunch of things in the chat as a final little plug. If you're interested in attending the workshop that's going to take place on the 18th of September in Minneapolis, that's part of TechX, the whole reason for Jorge coming in and joining us this month. I've thrown in the application, and the deadline is August 13th to do that application. If, you know, perhaps you have colleagues on campus that might be a better fit for attending the workshop, please share the application with them. And then also, we're in the final days for CC Star consultations, and if you are interested in getting some help with that, please contact Lauren Michael. I've thrown her email address into the chat as well, because I know that window of opportunity is closing, and a lot of references to CC Star have come through. So if the CC Star grant is what you need now, this is a good time with the September 11th submission. And with that, I'd like to see if there are any final questions. All right, y'all. Thank you very much for joining us this month. Jorge, thank you for doing this preview for the TechX workshop. We really appreciate it. And I hope everybody has a wonderful remainder of July, and we'll see you all around in August. Thank you.
Thank you very much, Emily. Thank you all.